Hi students, and we're taking a look at linear functions here, specifically slopes and points and their relationships. So the equation for a linear function can be determined by just a single point and the slope. Now, before we get to that, we have to show how to generate additional points from knowing a single point and the slope. So that's what we're going to do in our example here. So we have a function has a point 2, -5. That means the point 2, -5 satisfies that function. And the function has a slope of 3/7. We want to determine points satisfying the function on either side of 2, -5. So to help us out, I'm going to help us visualize this by graphing these points. So I have the point 2, -5. And what I mean by points on either side, I mean points, any point that is to the left and to the right. Okay, so that's what we mean on either side. You can also think of it, I guess, on a point above and a point below, but by side we're generally meaning left and right. So how on earth can we do this? Well, we're going to use some helpful definitions. So remember that slope is equal to rise over run. And another helpful one we're going to get to in just a moment is it's also thought of as the change in y over the change of x, right? So we can use these two interpretations of slope to help us. So in our case, we have a slope that has a value of 3/7. So what that means is it has a rise of 3 and a run of 7 between any 2 points. So we're going to use that ratio to help us out. So for instance, from this point, if I rise by 3, 1, 2, 3, and make a horizontal movement to the right by 7, 1, 2, 3, 4, 5, 6, 7, I can get another point on this graph. So right there. So we're going to do a similar trick to get this next one, but we have to use fractions to help us out. So if I take 3/7, remember that this is equal to -3 over -7. So I can think of this one, let's use blue, I can think of this as going down 3 and to the left 7. So I'm going to show that's true from going from the green dot here to the blue dot. So if I go down 3, 1, 2, 3, and then to the left 7, 1, 2, 3, 4, 5, 6, 7, notice I get back to the exact same point. So this satisfies our condition. So now I can go down another 3, 1, 2, 3, and left another 7. 1, 2, 3, 4, 5, 6, 7. And notice that I get all 3 points on a straight line, which confirms that our answer is looking very correct. So how could you do this without using a graph? Because you aren't always going to be provided a graph. Well, we're going to use the definition here of rise and run in terms of change in x and change in y. Let's grab a good pen here. There we go. Okay. Oh, no, wrong one. That's the one I wanted. Sorry. So I'm going to use the following formula. Sorry, still didn't grab the right pen. So if I have, let's say, my coordinates of 2, -5. So if I have a change in x, I can either add that change or I can subtract that change. If I have a change in y, I can either add that change or subtract that change. Okay? So this is a way to get from one set of points to another set of points, simply by using the definition of slope as change in y over change in x. So to get to my green point, what I'm going to use is I'm going to add both of them. And here's the trick. You want to be consistent. You're either going to be adding both the delta x and the delta y, or you're going to be subtracting both the delta x and then the delta y. So the trick here is you also have to be careful of signs. So this one's nice because both of our delta y and delta x are both positive, so +3 over +7, so we're safe for now. So let's take a look at putting this together for adding our change. Oops, just lost my pen. Ooh, there it is. There it is. So I'm going to have, for my green point, 2 plus my change in x. Now, what's my change in x? So delta x here, remember, is on the bottom. So ordered pairs come in x first, then y, but your slope comes delta y over delta x. So don't get those two confused. So I get 2 plus 7, and then I get negative 5 plus 3. And this gives me the point 9, comma, negative 2. And if we map out 9, negative 2, notice that I get exactly my green point there. So we know we're correct. So let's try the same for our blue. I want you to pause the video and try this one out. And what you're going to do is you're going to subtract both the delta x and delta y in this case. So what we're going to have is I get 2 subtract 7, comma, negative 5, subtract 3. And this is going to give me the coordinate negative 5, comma, negative 8. And we can check that this point here is exactly at the coordinates negative 5, negative 8. So this is how we solve for a given set of points, either to the left or to the right of a given point provided a slope. Let's take a look at another example here. So I want to update you with a little bit of notation. Notation update. Slope is rather long for mathematicians to keep on writing again and again. So we use a variable to denote slope. And that's our cursive m. So mathematicians work very hard to be very lazy, so often we'll denote long, cumbersome words like slope with its 5 letters with just one single variable. So we have slope is the same as writing m, the same as rate of change, the same as common difference, the same as delta y over delta x, same as rise over run. So just remember that it's a lowercase cursive m here. So how can we determine slope from 2 points that satisfy a linear function? So we're given the following equation in our book. Ooh, just need to erase a few guys hanging out here. So our textbook gives us the following. Slope is equal to m is equal to y2 minus y1 x2 minus x1 for the given points x sub 1, y sub 1, comma, x sub 2, y sub 2. So this is kind of overload at this point. We've got all these numbers, all these letters. What's going on? Mr. Willard, please help me. So I will do the best that I can to help you out here. So the book kind of overcomplicates things. So we're going to slow it down with an example. So I'm going to give us a set of points. So let's say we have 2 and negative 9. And let's do negative 3, comma 4. I want to know what the slope is between these 2 points. And that's the same as asking, what is the slope of the function which these points satisfy? So let's take a look. I'm going to just match these up. So for instance, my x1, I'm going to think of it as 2. My y1, I think of as negative 9. My x2, I think of as negative 3. And my y2, I think of as 4. So really all we're saying is I'm going to think of this set of ordered pairs as my first point, and that's what the little subscripts denote, x1, y1. And I'm going to think of this ordered pair as my second point, and that's what the x sub 2, y sub 2 denotes. Okay? Which points are your first point? Which points are your second point? So let's make a list here. So we need to find out some of our y's. So y2 is 4. y1 in this case is negative 9. We have to be careful to keep the signs. x2 is equal to negative 3. And x1 is equal to 2. Now that we have these values here, what we're going to do is we're going to substitute them into this equation to find out what our slope is. So what we're going to get is slope is equal to, well, my value of y2 is 4, value of y1 is negative 9, so I'm going to subtract negative 9. And I divide this by my x2 value of negative 3, and I subtract my x1 value of positive 2. Now simplifying, I get 13 over negative 5, and I can express this just as negative 13 over 5. So you may be wondering, well, Mr. Woolard, what if I swap these around? What if instead I called this my second point and this my first point? So let's solve that question as well. So I'm going to draw a little line here. So let's say that I had 2, negative 9, and this was my second set of points. So this is x2, y2, pardon me. And then I had negative 3, 4, and this was x1, y1. So we're going to make our list again, except the values are going to be a little switched. So my y2 in this case is going to be negative 9. My y1 is equal to 4. My x2 is equal to 2. And my x1 is equal to negative 3. So what I'm going to do, I'm just going to move this up, and then we're just going to apply our formula. So I'll write out the formula again. So it's your slope is equal to y2 minus y1 over x2 minus x1. So we're going to get the following. I get negative 9, take away 4, divided by 2, take away negative 3. And simplifying, I get negative 13 over positive 5, which again simplifies to just negative 13 over 5. So here's a handy little review. Remember that 13 over negative 5 is the exact same as negative 13 over positive 5. Okay, so remember that as far as fractions go, when they're negative, you get one negative sign, and you get to decide where you spend it. You can spend it in the middle, meaning that you're just saying everything, the whole thing is negative, or you can spend it in the numerator and saying the denominator is positive, or you can spend it in the denominator saying the numerator is positive. So that's a little bit of Math 8 fun time review. So let's take a look at where this equation really comes from. Oops, sorry, I need to grab my hand. So we have slope so far. We say rise over run, and let's take a look at this definition, delta y, delta x. So how do we express a change in y? So let's say that I have my points. I have my x sub 1, y sub 1, and I have my point x sub 2, y sub 2. So this is my first set of points, second set of points. How can I find out what the change in y is? Well, remember, change, another way to think about it is just what's the difference between two things. So difference is subtraction. So y2 minus y1 divided by what's my change in x. And remember, we just want to be consistent. If I'm taking the first from the second, I want to do it both for y and for x, or else we'll get some sign errors. So now I have x2 minus, x1. So really it comes down to the definition of change being the difference or the subtraction between two values.